All right, we have been working in section 3.1, and the last bit of information we're going to cover today, we're working with taking base systems and going in and out of other base systems and into or out of our own. So this is where we ended last time, is talking about converting base whatever into base 10. And if you would go back and put in big, bold, highlight, circle, whatever it takes, the whole goal, the whole process here is hinged on multiplication, right? Eventually you multiply by the base powers. Okay, multiplication. So write big, bold, circle, multiplication. Because we're about to go the other direction, which means instead of multiplying, what do you think we might do? We will divide. So this is one of those things that, would be a good idea to put on your note card to remind yourself when we get to that point. Which one did we multiply, which one do we divide? Because I always have students who reverse the two at some point, all right? So our conversions for today are going to be taking our base 10 system and turning them into some other base. And we've actually done this before. We did it with the Mayans when we divided by powers of base 20, or the modified base 20. And we did it with the Babylonians when we divided by powers of base 60, okay? And it looked like a top hat. Do you remember that? So that's what we're doing again. All right, so here's our example. It's 11028 base into base 4, so 11,028 into base 4. So imagine somebody coming in, and after your jaw drops, you pick it up, you go, okay, this is what I do. They dropped 11,028 crayons on the floor. Would your jaw drop? Mine would. It's a lot of crayons, and they're all over the floor, all right? And we're going to put them in bags, but we're going to put them in bags of sizes related to base 4. So what does that mean? Well, we always have 4 to the 0, which is the number 1, or whatever to the 0, which is the number 1. And then we do a power 4 to the 1 is a 4. What is 4 squared? 16. 4 cubed? 64. 4 to the 4th. 256. 4 to the 5th. 4 to the 6th. Okay, we're going to do one more because you'll see why. What is 4 to the 7th?
16,000.
Yeah, and the answer really to that question is it's too big, right? It's bigger than the 11,000 I have, so that's how I know to stop. Yes,
So
ma'am?
whatever base number, you would go until you reach a number that is more than the original number?
Exactly. So you take whatever the base is that you're going to try to put it into and do powers of that base until they get too big.
Okay.
Exactly. All right, so we're going to be dividing by these numbers, starting with the biggest one first, obviously, and we have to divide by all of them. So sometimes when we divide, we might get 0, and that's okay, but we have to divide by all of them. So we'll start with 4096, and we're dividing the number we were given, which is 11,028. All right, so your calculator is going to be your best friend right now. How many times will 4,096 go into 11,028? Twice. And what is 2 times 4,096?
8,192.
Okay, and we subtract. So, what do we get when we subtract?
2,136.
All right, good deal. Okay, what's the next power I'm going to divide by, or the next value I'm going to divide by? Yep, 1,024. So how many times will 1,024 go into 2,836? Twice. And what is 1,024 times 2? 2,048. So when I subtract, what do I get? 788. What will I divide by next? 256. And how many times will it go n? 3. 256 times 3? Okay. And if I subtract, what do I get? 20. What will I divide by next? Okay, so this is the one where it feels awkward, right? 64 is my next value, so I will divide by it. It just doesn't go in. So there's just 0 because it's a placeholder. All right, it's like giving change back to somebody and they don't have any 5s to give back to them because they don't need any 5s, right? So you give them 0 5s. It's a placeholder. So this goes in 0 times, and I still have the 20 left over. So what will I divide by next? This should keep going, but I'm out of space. So 16. So how many times will 16 go in? Once. So minus 16 leaves me with 4. Divide by 4. And it will go in 1 time. The remainder here is actually 0, and it's tempting to stop. We have to keep dividing until we get to 1. And it will go in, of course, 0 times at that point. And here's the cool thing about this particular algorithm. I absolutely love this because your answer's right here. Just straight down. And because we're not doing Babylonians or Mayans, I don't even have to change symbols. It really is these numbers. So it's 2, 2, 3, 0, 1, 1, 0. And then at the back end, we need to write a subscript that says 4 so that we realize we're in base 4. It's good stuff, right? Yeah. Any questions about how we worked that or any of the details of that problem? Okay, let's try one more. Same question, converting. We are converting 99,999 into base 9, which means I need to know what the powers of 9 are. So 9 to the 0, 9 to the 1, 9 squared, 9 cubed. So 9 to the 0, of course, is 1. 9 to the 1 is 9, and 9 squared is 81. So those are probably all the ones you've memorized. What is 9 cubed? 729. 9 to the 4th? 6,561. 9 to the 5th? 59,049. And while I could do one bigger, you probably can look at this number and the number I'm dividing, going to be dividing something into, and know I'm done. I don't need to try another one. I've got a number that's big enough. Does everybody understand what I'm saying? Because 59,049 goes into 99,999 how many times? Just once. 59,049 subtracted gives me what? $4,950. What will I divide by next? Good, 6,561. So how many times will 6,561 go into 40,950? 6, And 6 times 6,561?
39,366.
Good. What do I get when I subtract on that one? 1,584. Lovely. And I will divide by 729, which will go in, I think, twice. What do you get when you multiply by 2?
1,500.
Perfect. And I subtract. And I get 126. And I'll divide by 81, which would go in once. Yeah. Subtracting, I get 45. I'm kind of out of space, so I'm going to just come up here. What will I divide by next? 9. And how many times will 9 go in? 5, which is exactly 45. So a remainder of 0, but I still need to divide by 1, which goes in, of course, 0 times. So what is my answer? Okay, so we don't want to say 162. Yeah, because 100 insinuates that we're dealing with the hundreds in base 10, and we're not. So it's 162,150, and then base 9 with a subscript with the word 9. Any questions on that? Good job, guys.